So at this point, we're going to check the voltage of these two transformers combined. I would have done the combination, but I've already adjusted the wires on something else. So I'm going to check the voltage generated by this transformer on the secondary winding. I'm going to check the voltage generated by the second transformer on the secondary winding as well. And then I'll sum the two together. So that will give me the total voltage produced by the two of them put together. I'm supposed to connect them in parallel, but the wires are already busy somewhere, so I'm going to do them individually. And then also, it's expected that the voltage be between 30 volts to 40 volts for it to weld continuously. Okay, so we are very much anticipated, or let me use the word very much sure, that it should be within that range. So let me quickly put on the generator and get that started. Sorry, the generator noise is going to be a challenge, okay? So you may not hear me easily, but I'll try and be very loud. So now I'm going to connect these two terminals on this particular transformer. That's one. And that's two. Next, take it to, that's it, 750 volts, okay? So at this point, we're going to have this here so that you can see clearly. So, I'm going to put it on now. These are the two terminals. First, then the second. So it's on. We have roughly 15 volts. So 15 volts generated by this. Then we have 20 volts, okay? So 15 plus 20, that's 35 volts in total. So both of them are going to work together to give us 35 volts, right? Alright. So if I have to change the, find the voltage that is running through the primary source, so we have roughly 222 volts. That's what is coming through the primary. And what's coming out of this secondary winding for the second transformer is roughly 20 volts, okay? Alright. Boom. All right, gentlemen and ladies, this is how it looks like. I've not done the coupling because I want to do an overview video of the entire procedures or the entire process. So this is how it looks like. Okay, my office is messed up right now because I've been working on this. So this is just an overview of how the welding machine looks like. This is the dashboard. Okay, so every detail will be explained. These are the fans, these are 2 transformers and all that. So basically, let's start with the input power. Okay, now voltage coming from your socket is 220 to 230 volts. Okay, now the basic principle behind the whole system is you being able to reduce 220 volts to 40 volts, or between 30 to 40 volts to weld. That is the voltage required for welding, 30 to 40 volts. Once you can achieve that, you can have continuous welding without having any issue with it functioning properly or not. Now, how did the whole system begin? In case you have not watched the videos on how the procedure started and everything, you can go through my playlist. You're going to see the procedures on how the whole project started and where it has gotten to right now. But here is an overview of how it works. So basically, it started with 2 basic transformers, okay, A and B. Now, these 2 transformers are coming directly from a microwave machine, a condemned microwave machine, okay? Make sure you don't pick a condemned transformer. Now, if you dismantle the transformer coming from a microwave machine, you can use it to design a welding machine, and that is exactly the procedure we are doing here. Now, what is the working principle? A transformer can either be a step-up transformer or a step-down transformer. What we are having here is an example of a step-down transformer. Why? Because it reduces 220 volts down to 40 volts required for welding, or 30 volts required for welding, as the case may be. So what actually happens here is each transformer comes with already his own primary and secondary winding. Okay, so we have to lose the secondary winding and then make our own secondary winding. Now, the number of turns you're going to use to achieve this secondary to achieve this voltage is dependent on the number of volts you generate per turn. In this system, for example, so the number of turns here is lesser than the number of turns here. And the reason is because this is a smaller transformer compared to this in terms of the space provided for the secondary winding. Now, we have a total of 17 turns here, while here we have a total of 23 turns. If you sum everything together, it's roughly 40 turns, okay? Now, each turn, from my observation, is expected to give me, or gave me rather, 0.84 volts. So if I'm having 0.84 volts per turn, it simply means for me to get a voltage between 30 to 40, I need a total of about 40 turns. So I succeeded in having 17 winding here, and how many here? And 23. So these windings were all done in one loop, the same line coming through here, having another loop, and coming out as output. Now these turns you see here are in series, while the 2 transformers that you see here are connected in parallel. The essence of connecting these 2 transformers in parallel is so that both of them can function as one transformer. If you connect them in series, trust me, you're not going to get a very good output from it, because they are going to be working as independent transformers. But as for the winding, they are working in series, so the total number of volts generated here plus the total number of volts generated here gives us 35. This one gives us 15 volts, while this one gives us a total of 25 volts. And by the time you are able to, I say 25 or 20 volts, by the time you're able to add both of them together, it gives you a total of 35 volts, as the case may be. Now, this 35 volt is already within the particular voltage required for continuous welding. How is the connection or the electrical part done? This is the first transformer. You see the wire going through here and loops here. This is the second transformer. You see the wire going through here and loops here. Now, these 2 output terminals are now connected to a voltage regulator. What you see here is a voltage regulator, okay? So this voltage regulator that you have here, actually the main function of it is to increase or reduce the voltage which you are using to weld. If you turn this knob to the maximum level, it will give you 220, 230 depending on the voltage coming from your source. And then if you reduce the knob, it will keep reducing, and you see it from the voltmeter here. And the voltmeter reading will just be giving you updates of the voltage increase or decrease as you are turning this knob, right? Good. So the voltage regulator is simply here to regulate the amount of voltage. So the leg coming from this one goes through the voltage regulator. The voltage regulator outputs itself and it goes through the power source. Now if you look at this wire, sorry the way everything is looking here is a little bit not in order. It's because I'm just rounding off the work, so I have to quickly shoot this video. These two terminals you see here are coming directly from this source you see here. Good. So it feeds through here, and that is the switch you see here. Now the 220 volts coming from here will go through here when I switch it on. On going through here, the first leg goes through this wire and then gets connected here. Now from here, it goes into the voltage regulator. The voltage regulator can increase, decrease depending on your turning of the knob, and the output of the voltage regulator will flow through here and then enters the transformer. That's the first transformer, then to the second transformer in parallel, and both of them functioning as one. Now the second leg coming from your AC supply goes through and meets at this junction. Now on getting to this junction, it now feeds back to the transformer itself. You see, the second leg is coming from here. These are the two terminals for power supply, okay? So it goes through the transformer here and loops back here as well. And then also I have my voltmeter connected through the second leg. And the voltmeter you see here is what you see outside just here. Now, this winding that you see here that has been achieved in series is what comes out as output through here. And then you have this connected to your handle, while the second part comes out from here and is hard connected as your earth, okay? Now remember, it is one full long wire, so definitely it has two terminals. So the first terminal is what goes to your handle, the second terminal goes to your earth. If you take any one to handle, it doesn't mean. If you want to interchange them, it's not a problem, okay? So any of them will just do the work and do the work very well for you. Now this casing is designed with some fans, because a time will come when you use these transformers to weld, you're going to generate some amount of heat on the transformers, okay? So there is need for it to be cooled in the process. There is need for it to be cooled. So these transformers that you see here will be cooled by the help of these two fans, okay? These are actually two DC fans. They are 12 volt fans powered through AC by the help of an adapter, okay? So this is an adapter. These are the terminals of the two fans. So they go to the AC source here. So on reaching the AC source here, it goes through the adapter. The adapter steps down the voltage that is entering this particular 1 to 12. Remember, it picks 220 volts from here. It goes through the adapter steps it down to 12 volts required to power these two fans. And the two fans you see here are connected in parallel, okay? So by the time I put it on, they function as well as one. So basically, this is the working principle. Oh, sorry about that. So this is the working principle of this amazing setup. So the next thing we're going to do right now is to couple everything and make things just the way they are supposed to look. This is just a rough test of how it looks like. Let's play it and see what comes out of it.